Okay, so section 1.1, reducing fractions. We're going to really kind of review concepts here of how to reduce fractions. This isn't something that's probably, likely to be something you see on a test at this stage, but this is something that's involved in a lot of the problems that we do. So I want to make sure we're clear on it before we really get into the more complex problems. So when we talk about reducing fractions, really what we're trying to do is eliminate common factors from the top and the bottom. And we'll just do this for one simple example so you can see like why this actually occurs. And then we'll kind of just focus maybe on how to actually execute the reduction of the fractions. So if I see here an example of a fraction, 8 over 12, and you may already see like the best way to reduce this or what the outcome will be. But really, if I think about what I'm doing when I reduce fractions, I'm breaking down each number, the numerator, the top, and the bottom, the denominator, into factors. Right? 8 is 2 times 2 times 2, and 12 is 2 times 2, which is 4, times 3 is 12. So if I break it down into factors, I can see that really what I'm doing is multiplying. Here 2 over 2 is 1, and 2 over 2 is 1, and what I have left over is just 2 over 3. So that's kind of why it works, and we're not going to make you write out the factors every time, but I think it is helpful if you actually see like why this is happening. Kind of what we end up doing most of the time is trying to find the largest common factor that goes into both. So here we spelled out all the factors, but if we find the largest one, which I actually see here, 2 times 2 is 4, and 2 times 2 is 4. So typically what we would do is see what's the largest number that goes into both of these numbers. So 8 divided by 4, and the bottom, the denominator, 12 divided by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. So we're going to kind of use this method here because it's a lot faster than writing out all of the individual factors for each, the top and the bottom. So, but I did think it was important to see kind of why that works. So you can see here in our other example, rather than doing the factors like you see here, if I have negative 6 and then 12, what's the largest number that goes into 6 and 12? Well, 6 goes into 6 and 6 goes into 12. So if I divide each of those, negative 6 divided by 6 is negative 1, and 12 divided by 6 is 2. So you can see that matches the answer there. So we're going to kind of use that second method because I think it's a lot faster. So we're just going to run through some other examples. These actually will be pretty fast, and this will hopefully have us set up to be successful on the rest of our problems coming up throughout the whole year and the rest of our math careers that involve a lot of fractions. So again, what we're going to do is take the top and the bottom and divide by the largest common factor, the largest thing that goes into both of those numbers. And we'll see if I divide by something that goes in and it's not the largest, then I may be able to keep going, and we'll maybe do an example where we do that on purpose. So here 70 and 90, right? The largest thing that goes into both is 10. So if I divide each of those things by 10, 70 divided by 10 is 7, and 90 divided by 10 is 9. I'm going to write these maybe a little bit bigger because 10 is a little bit too big for that small part. So 4 over 36, the largest, right, number that can go into each of those. 4 definitely goes into itself, and 4 also goes into 36. So 4 goes into 4 one time. 36 divided by 4 is 9. Okay. Kind of continuing here. Again, I'll write it just a little bit bigger so it's easier to see. So 35 divided by 42, those are both multiples of 7. All right, so if I divide both of those, or each of those by 7, 35 divided by 7 is 5. 42 divided by 7 is 6. All right, so 5 over 6. 4 over 45. So here's a good example of a slightly different case, right? So if I think of the factors of 4, what are the numbers that go into 4? Right, 1 obviously, but if I divide by 1, that doesn't really change anything. 2 goes into 4, but 2 does not go into 45 because it's not an even number. 3 does not go into 4, but 4 does go into 4, but 4 does not go into 45 evenly. So 4 over 45, there are no factors that go into both the number 4 and the number 45. So that one right there is already the most reduced you could possibly get. Eight divided by 20. So typically, like if they're both even numbers, you know you can at least divide by 2. So this one I'm going to divide by 2, just to kind of show you what happens. Right? If I divide by 2, 8 divided by 2 is 4, and 20 divided by 2 is 10. I can recognize here too that 4 and 10 are also even numbers. So I can divide, use my other color again, if I divide each of those by 2 another time, 4 divided by 2 is 2, and 10 divided by 2 is 5, and there's nothing that goes into 2 and 5. So if I divide by a factor, right, like over here, I divided each of the top and the bottom by 2, which is totally allowed, but I ended up with a fraction that was still not all the way reduced. So I did that on purpose to kind of demonstrate, like, if you recognize that maybe they're both even numbers, you divide by 2. After we do that, we might see there's actually another factor that we can reduce by another time. So we'll finish up with these last two. They're pretty fast actually. So 10 divided by 40. So I was always taught anytime you have a 0 at the end, you can kind of just cross them out. So maybe that's something we can show right there, right? Because the zeros will end up canceling out. Because if I divide both of these by 10, right? When I multiply something by 10, I add a 0. When I divide something by 10, I lose the 0. So I would end up with 1 over 4. And I can see that's the same thing as if I crossed them out at the beginning. And then the very last one here, 42 divided by 60. So this is a good example to show again, maybe I don't recognize anything other than they're both even numbers. So I'm going to divide by 2. 42 divided by 2 is 21, and 60 divided by 2 is 30. And here they're not both even numbers, but I do recognize that 21 is a multiple of 3, and so is 30. So 21 divided by 3 is 7, and 30 divided by 3 is 10. 7 and 10 do not have any common factors, so that's the least or the most simplified version of the original fraction. Right? If I would have taken 42 over 60 at the very beginning and divided each of those by 6, right? 42 divided by 6 is 7, and 60 divided by 6 is 10. I would see the same answer, right? Divided by 2, divided by 3. If I do both of those things, that's the same as dividing by 6. So that's all we have for this section, I believe. Yes, that's all we have for this section. I do want to show maybe one more quick example that's not on here. We'll call it H. And all of these were fractions where they were less than 1. The denominator was larger than the numerator, but it's the exact same process if we have a fraction where we have the bottom, maybe I should do like this. That's not going to be an integer as an answer, but if I have something like this, I recognize they're both even numbers, so I would divide by 2. 32 divided by 2 is 16, and 14 divided by 2 is 7. And 16 and 7 do not have, 7's a prime number, so there's no common factors. So I can see there, it doesn't matter if the larger number is on top like it is here. It's the same process. You're dividing by a factor. In this case, we recognize 2, and then we see where we stand. If we can keep going, we do. So that's what we got for this section, kind of a refresher on reducing fractions, so that hopefully we can be successful as we start to do some other things.